All right, as we move on and continue looking at factor analysis, I want to make a quick little video here with this idea that underlying the factor analysis process is this idea that variables have to be correlated. And so we need to test, it is helpful to test in advance to confirm that the variables we're looking at share correlation together, and we call this the correlation assumption within this stage. Sometimes researchers don't do this step, but it's helpful to do this step, and it helps you move forward and have confidence in what you're doing. And remember, we wanted to, setting up the data and looking at it, you wanted to, in the back of your mind, be able to say, yeah, those variables probably go together, so they should be in the factor analysis. And if you can't really do that on the face of it, then you might want to do these steps to be able to judge whether statistically whether they'll go together or not. If you don't do this, if you don't do stage number 3 here, if you don't take a closer look at the intercorrelation between your variables, it'll come out in the end. I mean, you'll realize in the end that some variables maybe didn't go together. So this will be picked up in your final analysis one way or another, but this is a step that may be handy. It might save some time in the end, but mathematically it's something that should be done anyways. So there are 4 different evaluations, if you will, of your variables to confirm that they should go together statistically based on correlation. The first is to simply look at a correlation matrix. So if you call for the correlation matrix for your variables, if you run that, get a correlation table or matrix, then you can look between your variables and look at the individual bivariate correlation. Bivariate meaning each individual variable. And we want variables that are highly correlated. Okay, so this will be, you don't necessarily have to look at significance level because significance is driven so much by sample size. But if you look at the absolute value of the correlation coefficient between 2 variables, if it's greater than 3 or 4, then you're probably in good shape. If it's above 5, then you're certainly going to be in good shape. So when you look at the correlation, if you think that variables should go together, and then you look at the correlation matrix and you see that they correlate with each other, again, at something above 0.3 or 0.4 or 0.5, then your suspicion that the variables go together is probably confirmed. Okay, so that's the first thing that you can do. It's easy to do. Generally speaking, when I do research, I always look at a correlation matrix first so that I can begin to understand how variables may be related to each other. Second thing you can do is look at the anti-image correlation matrix or the partial correlation matrix. So again, in your statistical software, if you call for the partial correlation matrix, then what you're going to look for is the diagonal scores, which should all be high. And then so if you have a matrix and you look at the diagonals, it would be the boxes where the variables are the same. So if you have variable 1 in a column and variable 1 in a row, look at that box for variable 1. That's the diagonal matrix. That's the diagonal. That measure, that indicator there should be above 0.5. That's ideal. Anything in the off matrix should be below 0.5. So the off diagonal entries should be small, the diagonal entries should be large. So the partial correlation matrix is a second look at this. Third look would be to do a Bartlett test of sphericity. So the Bartlett test will help us understand, and it is a test with an alpha value, so it's like a significance level. So the Bartlett test will test for It'll test for correlation within all the variables together. So to confirm that there are levels of correlation that you would expect. And then the measure of sampling adequacy, which is actually the most important thing, or the MSA, sampling adequacy measure, is the most robust, if you will. It's the most confirmatory, if you will, of the four here. So we do an MSA by item. And again, we've got a 0.5 rule where we have a greater than 0.5 or less than 0.5, which we also had at on the anti-image correlation matrix too. So that's what you'd look at there in terms of double checking and looking at these intercorrelations. Okay, so when we look at partial correlation, like I mentioned just before, we are looking at the correlation between two variables after the effect of all the other variables in the database has been eliminated. So, so we have like a system of variables, and we have correlation among all of them, maybe. And when we take out all the other variables, interrelated correlations, we have just the correlation between two. That's it's like a partitioning of correlation, if you will, between the variables. So the coefficient should be small, which would indicate that the designated variables, which have already been removed, have accounted for the relationship between the two variables. Okay, so it's like again, it was the anti-correlation matrix, which is really what you're looking at. It's like the disassociation of variables that's going on. Again, to run the practicality of it is to look at the partial correlation matrix and consider the rules that on diagonals will be 0.5 or greater, off diagonals will be less. Again, the Bartlett test, as I mentioned before, you want to look at the entire correlation matrix to confirm that within the entire correlation matrix there is sufficient correlation that's happening somewhere. So then that's what we would look at. Again, it is a test statistic, so we have a significance level. It's often at the 0.05 level that can be used in order to test the overall correlation. Be cautioned, however, sample size pushes this test. So Bartlett test can be more sensitive with sample size. So if you have a large N, so this is true about a lot of things. If you have a large N, you're going to have an easier time finding significance statistically. However, the larger the N is, your practical significance will decline. So even though, so for instance, if you have two variables that are correlated at 0.110, that's not very strong. Like a 0.10 correlation is fairly weak. And if you have a sample size of, say, 50, you're probably, that is not going to be significant. However, if your sample size is 1,000, then that will probably be significant. Yet statistically it's significant. Practically it's still a 0.10. It's still a 0.10 significance level. So practically speaking is a whole lot different than actual statistical importance here. So that's the problem with the Bartlett test, in that it may indeed yield a significant result, but those significance levels may not be really that important if you have a really high sample size. A more important or more robust test or indicator would be the MSA, the measure of sampling adequacy. This is going to be a measure or a result that falls between 0 and 1. The KMO test, the Kaiser-Meyer Olkin test is what you would often see reported. So the Bartlett test and then the KMO is the other test. And the KMO, again, is a little bit stronger of a test. And the interpretation guidelines then would be something greater than 0.5, again, is what you want. Something less than 0.5 would be less desirable. There's actually the M criteria, meritorious, middling, and mediocre. Those are kind of older terms from literature that have been used to describe how well variables would perform in a factor analysis. So doing the measure of sampling adequacy is beneficial for individual variables, and what we do is we run an MSA, and then we look at the scores for each variable, and if a variable falls below 0.5, then we eliminate it and then run the MSA again. And so this is an iterative process where we take each variable that's weak and we take it out and then run it again until all the variables have an MSA of above 0.5. So we run it again after we do our first MSA. We test again, and then we try to we go from there. So 4 things to look at. Correlation matrix. Number 1, it's easy to do. You want to find variables that go together just visually. You use the partial or anti-correlation matrix next to again look at potentially weak variables. Those would be variables on the diagonal matrix that have less than 0.5 correlation, and on the off diagonal matrix components or entries would be, we want them to be small. They should be small in that case. So we look for that. The Bartlett test for specificity, the Bartlett test then is not as strong of a test because it's fairly sensitive to sample size. It also looks at the overall correlation matrix as a group as opposed to individual variables, and then the measure of sampling adequacy. So the measure of sampling adequacy we would think of as the best measure to use in terms of identifying variables that should indeed go together.